2.75G of digital mobile networks, or sometimes commonly called as EDGE, stands for Enhanced Data Rate for GSM Evolution, or EGPRS stands for Enhanced General Packet Radio Services. Second generation of mobile networks began in the 1990s, primarily by using the GSM standard. This generation of mobile technology, comparing to the previous version, which is the first generation, basically differs in terms of transmitting data. As we can see in this figure, 2G technology uses digital transmission, while the first generation uses analog transmission. These are some problems arise on the previous second generation of mobile networks. One of these is they require strong digital signals to help the cell phones to work. If there is no network coverage in any specific area, the digital signals would be weak. The systems are unable to handle such complex data such as video, music, and other types of various media files. The speed is also up to 144 kilobits per second, which sometimes cannot support downloading a large media files. As the years go by, the demand of the people on the internet increases dramatically. New variant types of communication in second technology were introduced, like SMS, became possible initially on GSM networks, but eventually on all digital cellular networks as well. Today's fast-growing world needs fast communication. Either it may be voice, video, or data. This calls for a new technology which has high data rate so that the transfer of data from one point to another is faster than existing technologies in mobile communication and hence can replace the previous 2G technologies. Edge not only enhances data rates but also intended for efficient spectrum utilization, which it has passed successfully. This technology is introduced to extend the capabilities of existing GSM or GPRS technologies. Or simply speaking, Edge is such a technology that is an upgrade of previous GPRS with enhanced data rate.
Now, for example, here is a mobile and we know that the mobile in the GSM network has an allocation bandwidth of 200 kHz frequency band in the uplink and also 200 frequency band in the downlink. And these two 200 kHz channels in the uplink and in the downlink is known as the duplex frequency, meaning that they can communicate with each other in both directions. And these two 200 kHz channels are further subdivided into 8 time slots. And what it means by that is that there are 8 time slots in the uplink and 8 time slots in the downlink. As I said earlier, in the case of GPRS or in the GSM, the mobile is using this one time slot in the uplink and this one time slot in the downlink. And in this modulation scheme, it basically uses 1 bit per symbol. But in the contrary part, which is in the edge, cannot only use the GMSK but also 8PSK modulation as well. And we all know that the 8PSK modulation, it can basically send 3 bits per symbol. This means that the transfer of data rate is 3 times comparing in the GMSK modulation. Since the 2.75G can use two modulation schemes, modulation adaptation is possible in here, meaning it can change the modulation technique whenever there are changes in distance from the mobile to the base station. When the mobile station is near in the base station, in that case, mobile station condition, radio condition for the mobile station is good. It means that they are receiving high power signal from the base station and it is getting less interference on the nearby mobile stations. So the mobile signal to noise ratio is good. This means that it can use high modulation scheme, which is the 8PSK modulation technique in the good channel condition. So it means that in this time slot, it will have 3 bits per symbol. It means that we are achieving a high data rate in the good channel condition. In the case of bad channel condition, in this case, the mobile station condition, radio condition is bad, and it means that it is receiving a low power from the signal from the base station, and it is getting more interference on the nearby mobile station. So in this case, Edge basically uses lower order modulation technique, which is the GMSK, because if we analyze it, if we use 8PSK, bit error would increase, and also it will be added to the interference on the nearby mobile station, and thus it will result to a bad signal. So in the bad channel condition, GMSK is being implemented with lesser data rate that is sending 1 bit per symbol. So this is known as the modulation adaptation of 2.75G. But not only modulation adaptation, it is also possible in terms of coding adaptation. Like for example, the channel condition is good, and while the mobile station is using these time slots either in the uplink and in the downlink, this time slot is out of the total effective data rate that the one time slot is carrying. We would use more bits for the data user information, and we use lesser number of bits for the error correction, because the total effective data rate of the time slot is basically the sum of the user information bits and the error correction bits. So if the channel's conditions are good, we don't need many for the error correction, so we use more data bits. This is basically and only implemented when we are near in the base station. Then we move away from the base station. The channel condition degrades, and in the case of bad channel condition, we need more bits for the error correction, and consequently, the user data bit would decrease. This means that if we move further away from the base station, we need more and more bits for the error correction. So the user data bits and the time slot would decrease. This is known as the channel coding adaptation, that we try to make use of good channel condition to have enhanced higher data rate when we are near to the base station. In the edge, we use the coding adaptation and the modulation adaptation. The combination of these two adaptation is known as the modulation coding scheme. And in this technology, it has 9 types of modulation coding schemes. For example, here in this case, mobile station has the best channel conditions using MCS9, or the modulation coding scheme 9. And in this case, we are using 8PSK modulation of a higher data rate, and we are using less bits for error correction. So the user data rate is 59.2 kbps, which is the highest data rate in one time slot. Now we move further away, then the channel condition degrade because interference is increasing. So we now use MCS8 that still uses 8PSK, because in this condition we can still use 8PSK for higher data rate, but we need more bits for the error correction. But if we use the MCS9 in here, error correction bits were less, so the error would be higher. So in order to decrease the error, we increase the error correction bits, so the data rate decreases. So in this case, it becomes 54.4 kbps. Now we move further away. In this case, we are using MCS7 now, and the MCS7 still uses 8PSK. This means that here we are using more bits for the error correction, and the user data rate basically decreases to 44.8 kbps. And moving further away, same concept applies in the MCS6, that the data rate further decreases to 29.6 kbps because we are increasing the error correction. Then we move to MCS5, and it still uses 8PSK, but the error correction bits have increased, and the user data rates decreases to 22.4 kbps. We move further away from the base station, and we use the MCS4, and in this case, the use of 8PSK is no more favorable. So what we would do is to switch to GMSK, and it would mean that the data rate will be reduced because we no longer using the 3 bits per symbol, but rather in 1 bit per symbol. In this case, user data rate is 17.4 kbps. We move further away to MCS3, where the user data rate is 14.8 kbps, And for the MCS2, the user data rate is 11.2 kbps. And for the MCS1, which we have the worst condition, GMSK is using in here where the user and the mobile station is in the edge of the cell and the user data rate is 8.4 kbps.
So now, we discussed the comparison between the actual and the theoretical user data rate. We also know that in the best channel condition, we are using MCS9. This means that when we have the ideal channel condition and we are very near to the base station, in that case, in one time slot, we are getting a data rate of 59.2 kbps and a mobile can be assigned up to 8 time slots maximum. So then, the user is assigned to 8 such time slots. In that case, the theoretical data rate the user can get is 473.6 kbps. But in actual, we don't get that theoretical data rate. We get the data rate in few kbps, and the reason for that is because the actual data rate depends upon the number of data users in cell because these time slots are being shared between the mobile users in a packet-switch manner. So this means that it is not necessary that if there are many users data using edge network for data call, in that case, it is not necessary that the user can get 8 time slots. If it gets less time slots, the data rate would be less. So propagation conditions mean that we would not use the MCS9, but we may use other modulation coding scheme like MCS5 or MCS4 in the bad channel condition, and in the worst, we will use MCS1, and obviously the propagation condition depend upon the distance from the base terminal station.
So now we will discuss about other features of 2.75G. FDMA also is basically used in the edge technology that involves the division of frequency of maximum of 25 MHz in either uplink or in the downlink. And also, the 124 carrier frequencies is basically spaced 200 kHz apart. And one or more carrier frequencies is assigned to each base station. Also, TDMA is widely used in the edge technology. As we can see in the figure, it basically has an 8 time slots. The carrier multiplex in frequency are then divided in time using a TDMA scheme. This basically enables the different users of the single radio frequency channel to be allocated different time slots. They are then able to use the same RF channels without mutual interference. The slot is the time that is allocated to the particular user, and the GSM burst is the transmission that is made in the time. A single time slot is divided into 15,625 normal symbol periods. The physical content of a time slot is characterized as a burst. Each GSM burst lasts for 0.577 milliseconds. 8 of these bursts periods are grouped into TDMA frame. A TDMA frame lasts for approximately 4.615 milliseconds, and it forms the basic unit for the definition of logical channels. One physical channel is one burst period allocated in each TDMA frame. The Evolved Edge system provides for a scheme known as the receiver diversity, where a second receiver is used to decode the incoming signal in a way that it can receive with different characteristics, like for example, position or polarization. In this way, if the signal on the receiver is poor, there is a chance on the second receiver that it will be received with fewer errors. Also, one key element with the GSM, GPRS, and Edge technology was to basically save costs. This was done by using the time division multiplex scheme that would basically ensure that the transmitter and the receiver will be never active at the same time. This was achieved by using one slot for transmission and different time slots for reception. Even when multiple slots are used, one either side of the reception slots was kept clear to allow for transmit-receive setting. Evolved Edge allows for simultaneous transmission and reception as the cost for more effective filtering between the transmitter and the receiver. Most edge mobiles on the market are restricted to 4 time slots per carrier. Due to this phenomenon, having independent transmission and reception chains could allow mobiles to use all 8 time slots of a carrier. So now I will discuss the importance of implementation of edge technology. Edge basically requires no hardware or software changes to be made in the GSM core networks. Only the base station must be modified. Also, edge-compatible transceiver units must be able to install in the base station subsystem hardware. If the operator already has this in place, which is often the case today, the network can be upgraded to edge by upgrading and activating an optional software feature. Today, Edge is supported by all major chip vendors for both GSM and WCDMA or HSPA. Also, Edge improves in reducing delays. Latencies are being reduced by lowering the transmission time interval by half, from 20 milliseconds to 10 milliseconds. Bit rates are increased up to 1 megabit per second, peak speed and latencies down to 800 milliseconds using dual carriers, high symbol rate and high order modulation, and also turbo codes to improve error correction. And finally, signal quality is improved using dual antennas, improving average bit rates and spectrum efficiency. Edge evolution can be gradually introduced as software upgrades taking advantage of installed base with edge evolution, and end user will be internet connections corresponding to 500 kilobits per second ADSL service. So now I will discuss about the added feature that is existing in the edge technology. The first element that is added is the SGSN, which is the Serving GPRS Support Node, and the second one is the GGSN, which is the Gateway GPRS Support Node. The first one is the SGSN, the Serving GPR Support Node. It basically provides the number of takes focused on the IP elements of the overall system. It provides a variety of services to the mobiles, like for example, the packet routing and transfer, mobile management, authentication, attach and detach, logical management, and charging of data. There is a location register within the SGSN, and this stores location information like for example, current cell, current VLR. It is also stores in the profiles like IMSI packet address views for all the GPRS users registers to the particular SGSN. The last but not the least is the Gateway GPRS support node. The GGSN organizes the interworking between the GPRS and the Edge network, external packet switch networks to which mobiles may be connected.
Here's the summary of edge technology. In multiple access technology, it uses FDMA or TDMA. In duplex technique, it uses FDD. In channel spacing, it has 200 kHz. In modulation techniques, it uses GMSK, which has 1 bit per symbol, and 8PSK, which has 3 bits per symbol. In slots per channel, it occupies 8 slots. In frame duration, it has 4.615 milliseconds. In latency, it is below 100 milliseconds. Overall symbol rate, it has 270,000 symbols per second. Overall modulation bitrate has 810 kilobits per second. Radio data rate per time slot has 69.2 kilobits per second. Max user data rate per time slot has 59.2 kbps, which uses MCS9, and max user data rate when using 8 time slots is 473.6 kilobits per second. In conclusion, Edge is a filling gap between 2.5G and 3G. Edge evolution can satisfy increased data demand and produce increased revenue. Edge evolution will improve performance and coverage even further with bit rates up to 1 megabit per second. Edge will provide the solution for operators wanting to increase the data capacity in their GSM network prior to UMTS deployment.